Well, hello and welcome back to math. If you can notice, we are going to quickly get through this blue book. I want to be done with it so that we can get on to that beautiful yellow one. We're going to go ahead and look at lesson 25 today. You notice it's going to say a fraction as a percent. You notice we have some pictures of some cars and some trucks. I would like for you to go ahead and up here, I want you to write the words part to whole. Okay, part to whole. Well, part means obviously a portion of this, not all of it, and whole obviously would mean all of it. I would want to look at this picture and come up with some ratios of part to whole. What could I come up with? You're right, we could look at the cars. So we could say cars to whole. And if I did a cars to whole ratio, I would say, let's see, there's 3 cars. And we would say to a total of 5. Another part to whole we could do, obviously, would be we could do the trucks to whole. And if we did the trucks to whole, what would that ratio be? You're right, the ratio would be 2 to 5. Now, these are part to whole. Sometimes we might do what we would call part to part, which means we could do 3 cars, 2 trucks. But we're going to look at the whole group today. All right, so let's go down here and look at our first example. It says, Sam says 50% of the vehicles are cars. Give 3 different reasons or models that prove or disprove Sam's statement. Models can include tape diagrams, 10 by 10 grids, and double number lines. Well, I think we're going to kind of cancel this out, and we're not going to do 3 things. We're going to do 1. Most of us know that 50% is equal to a half. Well, if we notice, we have 5 vehicles. 3 of them are cars. Does that half? Doesn't look like it, does it? But we have to prove that. So let's go ahead and for our example, let's look at how many cars we do have. We have 3 cars. Remember up here, our part total, out of a total of 5 vehicles. Okay? 3 out of the 5 are cars. Percent. So we learned last week, if you were listening, percent always goes over the number 100. Always, always, always. So we want to get a percent over 100. Well, this is called the proportion. You guys have been done great with proportions. Some of you know we can do a couple things. We can either cross multiply and divide by 5. Or some of us know that we can multiply across this way. 5 times something is 100, and do the same thing on the top. Go ahead and see if you can solve for me what that number would be. If you got the number 60, you are correct. Now I did 5 times 20 is 100, and 3 times 20 is 60. So my answer actually is 60%. So 60% of these vehicles are cars. That's more than 50%. All right, well, let's go ahead and look down here at the first question. It says, how is the fraction of cars related to the percent? Well, here was our fraction. So we're going to say that 3 out of 5 is equal to, and we just solved up here, what was it equal to? It was equal to 60 over 100. We just proved that up here. And since percents are out of 100, so we'll write that down. Since percents are out of 100, the 2 are equivalent. Okay, so we just proved here that 3/5 was equal to 60 over 100, which is 60%. They are equivalent. All right, let's move down here. Now we're going to make our model. Use a model to prove that the fraction and percent are equivalent. Well, I'm going to make a tape diagram. I would like for you to make a tape diagram that shows 3/5. So if we remember, that means we're going to do something like this. So we're going to make 5 boxes. So I have 1, 2, 3, 4, 5. I'm going to kind of lightly shade in here 3. So I have here my 3 out of 5. Okay. We have up here 5 vehicles. So let's do our vehicles here on the bottom. So we have 0, 1, 2, 3, 4, and 5. All right. So 1, 2, 3 of the vehicles up here are cars. These 2 are trucks. Okay. Now let's do our percents. Well, here's 0%. And we're going from 0%. Obviously, remember, percent always goes to 100. Let's see. We have to divide 100 into 1, 2, 3, 4, 5 boxes. 100 divided by 5 would be 20. So we would go 20, 40, 60, 80, and 100. So on the top row, we have our percents. On the bottom row, we have our vehicles. We colored here 3 out of the 5. So if I look here at the 3, it matched with the 60%. So we've proved through a proportion, and now we've looked at a tape diagram. Okay, last question on this page. What other fractions or decimals can represent 60%? Okay, well, we know that percent always goes over 100. Okay, so here's a fraction. Well, some of us know if we cancel out those zeros, we could put 6 out of 10. Some of us know that that actually reduces again, which would be 3 out of 5. So here we have 3 different fractions that equal 60%. If I look carefully, a decimal, this says 60 hundredths, right? Well, we could write it like this. And we learned last week that that is also equal to this right here. We don't have to put the 0, which would be 6/10, which we have right there. Great. All right, we'll go ahead and let's turn over to the next page. All right, let's look at example 2. We have a little story problem here. It says a survey was taken that asked participants whether or not they were happy with their job. An overall score was given, and it says here 300 of the participants were unhappy, while 700 of the participants were happy with their job. Give a part, here we go, part to whole fraction for comparing happy participants to the whole. Then write a part to whole fraction of the unhappy participants to the whole. What percent were happy with their job and what percent were unhappy with their job? All right, well, it's kind of nice here. They set it up for us. We have here the happy and the unhappy. We want a fraction, and the fraction we want, remember, is part to whole. So let's see, how many of them were happy? Let's go up here and reread. It says up here, 700 of the participants were happy. All right, so fraction. So fraction we know needs to be 2 numbers. We know that there's 700 that were happy. Part to whole. The whole, what would the whole be? Well, the whole would be everybody added together. So that means we have to take 700 plus 300. How many total people would that be? Well, that would be a total of 1,000 people. So our fraction would be 700 out of 1,000 were happy. Let's go to the fraction for the unhappy. Well, the unhappy, the part would be 300. And the whole would be 1,000. Now we have to change this to a percent. Percent goes over, what does it go? It goes over 100. Well, if we notice, this is 1,000. But I noticed a little trick. The rule is if I cancel out these zeros like this, I now have 70 over 100. There's my 100, so my percent is going to be 70% of the people were happy. What am I going to do over here to make the percent? Percent goes over 100. If I cancel out these zeros like this, I now have 30 over 100, so my percent is 30%. Okay, oh, now we have to make a model. Well, let's see. We're going to make some tape diagrams. All right, so if you notice, what I'd like for you to do is I want you to make a tape diagram here, and we're going to make 10 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you want to pause your video so that you can go ahead and make those 10 boxes, you can do that now. Okay, now that you have your 10 boxes, we're going to label our percent on the top. And we're going to put our people on the bottom. Okay, so our percents, we're going to go from 0. Obviously, what's the last one we're going to do over here? 100, because we want to go to 100%. If I take 100% and I have to divide it into 10 boxes, we're going to count by 10. So go ahead and let's count by 10, 20, 30, 40, 50, 60, and keep going all the way to 100. Okay, so we have our percents across the top. Okay, people will start with 0. And remember, what was our total up here? We have to go all the way to 1,000. All right, oops, 1,000 here, Mrs. Hawk. There we go. 1,000. What would be 1,000 divided by 10? You're right, it's 100. So we're going to count by hundreds. So let's go ahead and count 100, 200, and keep going all the way until you get to 1,000. Now, once again, if you need to pause this because it's going too fast for you, please do so. All right, well, we're going to check to see if what you and I put up here matches with down here. Okay, well, let's go ahead and look. Let's see. Let's look at our happy. So our happy people were 700 out of 1,000. Okay, so let's find our 700. Here's our 700 people. Let's circle it. According to this, 700 should have matched with 70%. It did. All right, let's look at our 300 out of 1,000. Here's our 300 people. And it should have matched with 30%. Very good. So we have our model here, and we have our fractions at the top. Remember, we're talking about part to whole. All right, so we're going to go ahead and skip exercise 1 right here. If your teacher would like to do that later with you in class, you sure can. But I'd like to go ahead and flip over here to page 109. And I would like to use this tape diagram here to answer some of these questions. So the tape diagram has been made for us. We can see it's from 0 to 5, and we have percents 0 to 100%. It says 80% is what fraction of the whole quantity? Well, let's find 80%. 80% is right here. Now we're looking for a fraction, so that means I need a number on top and a number on bottom. Well, 80% matches with the 4. And it says of the whole, what fraction of the whole quantity? So we're saying 80% is 4 out of, what's our whole? Well, our whole was 4 out of 5. Okay. This says 1 out of 5 is what percent of the whole quantity? All right, well, so let's go here. Here's the 1 out of the 5 boxes. The 1's right here. It matches with 20%. 50% is what fraction of the whole quantity? Let's see, 50. Oh, 50% isn't on here, but I know 50% would be right here. And so 50% was right here, and I have 2 and 3, and I'm in the middle. What would be in the middle? Well, most of us know it would be 2.5, right? So if I come down here and I write 2.5, but then I read the problem and it says fraction. Fraction, and we know that a fraction means we need a number on top and a number on bottom. Well, we have to be careful too because it says of what fraction of the whole quantity. Well, this is 2.5 out of the 5. So I'm really going to write something that looks kind of crazy like this, 2.5 out of 5. Well, I know that I really don't want to leave it looking like that. So I know that 2.5 can also be written like this, right? So we have that. But I don't want to leave a decimal up here, do I? So I want to change that. Let's see, what could I do? Here's the number 5. If I put a decimal right here, this is still 5, right? Yeah, it's still 5. And if I add a 0, that's still 5. I haven't changed it. Now the rule is whatever I do on the top, I have to do on the bottom. I could, if I move this decimal one place this way, and if I move it one place here, now I have something that actually is 25 over 50. So now I actually have a fraction. Number on top and a number on bottom. Okay, let's go ahead and move to the last question. 1 is what percent of the whole quantity? 1. So we need to look back up here at our 1. 1. Well, the 1 is right here. 1 is what percent? But if I look at this one actually represents 1 out of the 5 boxes. This one actually represents 2 out of the 5 boxes. But if I look carefully down here at my problem, it's not giving me 1 out of 5. It's telling me the whole number 1. No fraction. The whole number 1. Well, would you agree with me that the whole number 1 is the same as 5 over 5? Because 5 divided by 5 is 1. So if I look at this fraction, let's see. This is 1 out of the 5, 2 out of the 5. This one would be 3 out of the 5, 4 out of the 5, and 5 out of the 5 would be the whole 1 box, which would be a percent of 100. Okay, lots of things to comprehend today. All right, so go ahead and turn over to exercise 3, to the next page. And we're going to do a couple more models, and then we're going to go ahead and stop. So let's go ahead and look at here about Maria. It says Maria completed 3/4 of her workday. Create a model that represents what percent of the workday Maria has worked. All right, so we're going to work on this together. So here's my fraction, 3 out of 4. So let's go ahead and make a model here. Okay, do that. Let's see, I've got 4 boxes here. We're going to go ahead and color 3 out of the 4. Okay, so we made our fraction. Percents, we're going to do on the top, so we have a 0% here, and we're going to go up to 100% here. 100%. What would be 100 divided by 1, 2, 3, 4? 100 divided by 4. Well, most of you know 100 divided by 4 is 25. So we're going to count by 25s. So we have here 25%, 50%, 75%, and 100%. All right? And we're going to go here from 0, because remember we're counting up here by 4s. 1, 2, 3, 4. So it says create a model that represents what percent of the workday Maria has worked. Well, let's look. It says 3 out of the 4, which is right here. What percent of her work day does she have left? Well, if she worked 3 of these boxes, and we only have this 1 box left for her to work, what is that box going to be? Well, the difference from 75 to 100. Most of you don't have to do this. You know how to solve this in your head. It is 25%. She's worked 75%. She has 25% left. All right, so we're going to go ahead and stop there. Tomorrow, our lesson is going to be based on changing fractions to decimals to percents. Now, the thing we always have to remember is percent always goes over what number? Always goes over 100. Okay, I look forward to seeing you all tomorrow.